Okay, so now we're ready for some really, I think, powerful stuff. We're going to talk about now the mole relationships in chemical equations. Okay, the mole relationships in chemical equations. And specifically, we're talking about these ratios right here, right? 2 moles of iron for every 3 moles of sulfur for every 1 mole of iron, what's that? Iron 3 sulfide, right? Okay, so our learning goal then is to use the mole-mole factors for balanced chemical equations to calculate the number of moles of another substance. I'm sorry, use the mole-mole factor for one substance to calculate the moles of another substance in the reaction. Okay, so we're going to convert between back and forth. Now we do need to point something out here, that the law of the conservation of mass says that matter cannot be created or destroyed, and that no change in total mass occurs. The mass of the products is equal to the mass of the reactants, right? And so we're going to assume all along that in any balanced chemical reaction, what we start with in terms of mass is what we're going to end with, right? So let's look here. If you take gold, tarnish, okay, which is silver sulfide, and then I'm sorry, not if you take it. Sorry, it forms when silver reacts with sulfur to form silver sulfide, okay? So you got 2 moles of silver, 1 mole of sulfur gives you silver sulfide. All right. Now, if we take 2 moles of silver, that's going to be 215.8 grams. And if we take 1 mole of sulfur, it's 32, right? So what's the sum of that? 215 plus 32 is about 247, right? You see it? And there it is. Okay? That's the law of the conservation of mass, that what we start out with is what we're going to end up with in terms of mass. All right? Now, we've used balanced equations only recently, yes, true, but we've used them, and here's what we get from this, right? If here's a balanced reaction, 2 moles of silver for 1 mole of sulfur gives 1 mole of silver sulfide, okay? What we can get from that is this, that if we have 2 silver atoms and 1 sulfur atom, then we're going to get 1 formula unit of sulfur sulfide. If we have 200 silver atoms and 100 sulfur atoms, we're going to end up with 100 silver sulfide units, right? Why is it 100? Well, this 100 to 100 because this was 1 to 1. You see that? Okay. Now, if we have 2 moles of silver atoms and 1 mole of sulfur atoms, we're going to end up with 1 mole of silver sulfide formula units, right? 2 moles, 1 mole, 1 mole. Right? Why? Because this, and we get all this information from the balanced reaction. All of it from the balanced reaction. Now, the masses we don't get from the balanced reaction. The masses we have to get from the molar mass, right? So 1 mole of silver is 100.7 grams. And, I'm sorry, yeah, 1 mole is 107. 2 moles is, I don't know, what, 214, 215, something like that, right? 1 mole of sulfur is 32.07. And if you add those together, you're going to get, boom, 247. Okay? Does that make sense? All right. So let's now let's consider mole factors. We're going to call this stoichiometric factors. I'm going to call it stoichiometric factors, but your book doesn't use that term, I don't think, because it's a clumsy term, but a lot of chemists use it, right? It's an old term. So the mole factors, or the molar ratios, or the stoichiometric factors from an equation are as follows. 2 moles of iron and 3 moles of sulfur give 1 mole of iron 3 sulfide. Is that right? Yeah, that's iron 3 sulfide. Okay, so we can read it like this. 2 moles, 3 moles, and 1 mole, right? That means that our balanced reaction now, it is iron 3 sulfide, right? There it is, iron 3 sulfide. Now, what can we do with that? Let's look at the conversion factors we can get there. Now, the conversion factors that we can use are, for iron and sulfur, go like this. 2 moles of iron for every 3 moles of sulfur, or 3 moles of sulfur for every 2 moles of iron, right? Or if we want to convert between iron and iron 3 sulfide, we can say 2 to 1, or 1 to 2, depending on what we're trying to do, right? And sulfur to iron 3 sulfide is 3 to 1, or 1 to 3, depending on what we're trying to do. Okay, so let's do a learning check now. Let's do a learning check to help you with this. All right, consider the following reaction. 3 moles of hydrogen for 1 mole of nitrogen gives 2 moles of ammonia. Okay, the mole factor for hydrogen and nitrogen is going to be nitrogen and hydrogen. Oh, those are all nitrogens and hydrogen. Okay, so far so good. Well, it looks like it's going to be, can you see it? It's going to be 3, 2, 1, right? 3 moles of hydrogen, so it's not that one, right? 3 moles of hydrogen to 1 mole of hydrogen. That's right, okay? It's not going to be this one, so it looks like it's going to be, this is my answer right here, right? Because it's not 2 moles of hydrogen, it's 3 moles of hydrogen, right? So pause the video and do number 2 on your own. Okay, so I'm going to suppose you paused it, and I am going to do this with you, right? So a mole factor for ammonia and hydrogen is this. Well, we can predict it before we go. Ammonia is going to have a 2 in front of it, right? 2 moles of ammonia could be this one. 2 moles of ammonia could be that one. 2 moles could be that one too. All 3 of those have 2 moles of ammonia. And what's the one with hydrogen? Hydrogen needs to be 3 moles of hydrogen, right? So it's not that one. It could be that one. It is that one, right? There's 3 moles, but it's not hydrogen. Okay, so it is B, 2 moles of ammonia for every 3 moles of hydrogen. All right, so now let's do some calculations with mole factors. How many moles of iron 3 oxide can form from 6 moles of O2? So let me go back here to draw. The core chemistry skill is we're using mole factors here, right? How many moles of iron 3 oxide can form from 6 moles of O2? Okay, so what we're going to do is we're going to take our relationship. It looks like it's 3 moles of O2 for every 2 moles of iron 3 oxide, right? So it's going to be 3 to 2. Got that. Now we're going to have to set up a conversion factor. We were given 6 moles of oxygen, so there's our given right there. And we were asked for moles of iron 3 oxide, so we have that there. Well, if that's the case, then we're going to have to set up a conversion factor that crosses off moles of oxygen and introduces moles of, and there we go. There's my moles of iron 3 oxide, there's my moles of iron 3 oxide, right? So let's make sure we got the 2 and 3. It's 2 moles of iron 3 oxide, and there it is, 2 moles of iron 3 oxide. And it's 3 moles of O2, and there it is, 3 moles of O2. All right, so this is what's going to do it now. It looks like it's 2/3. 6 times 2/3, which, sure enough, that one we can do in our head, I think, right? Turns out to be 4 moles. Okay? All right, so let's close this conversation out with a learning check. Pause the video, calculate it, write it out on your paper, and then compare your work to mine. Okay, so I'm going to suppose that you paused it, and you've got some notes in front of you, your notes, and I'm going to start out by saying this. How many moles of iron? First thing I'm going to do, moles of iron, right? That's my answer. How many moles of iron? Okay, the next question is, the next thing we're given is moles of oxygen, right? So I'll come over here, and we're going to say moles of O2. So what we're going to have to do then is come up with a conversion factor that crosses off moles of O2 and introduces moles of iron. So I'm going to find, here's my moles of iron, and here's my moles of O2, right? So let's go here. Let's stay in blue. Moles of O2, moles of iron, right? That's what I was asked, moles of iron, okay. I got my moles of iron here, and my moles of O2 are going to cross off. It's perfect, okay? So let's put the numbers in now. Looks like it's 4 moles of iron for every 3 moles of O2, okay? It's 4/3. And the question is, I had 12 moles of O2, 12.0 moles of O2. 12.0 divided by 3 is 4, times 4 is 16. There it is. This is going to give me 16.0 moles of iron. Final comment about this. Notice that I was given I had 3 sig figs here, right? 3 sig figs here. Now these stoichiometric coefficients, these molar coefficients are exact. So this is exact and that's exact. And so my answer is going to have 3 sig figs in it, right? Now all these had 3 sig figs in it, so that wasn't necessarily part of the question, but just as a practice. All right, I hope that's helpful. I'll see you in the next lecture.